All right, so we're starting section 7.3 today.
Date.
It is February 26th, all day. February 26th. And we're going to begin talking more about functions today. So we've already talked about some functions so far this year. Back in chapter 2, we had problems that might have looked something like this. We might have had f of x is equal to x minus 7. And then we might have said, hey, can you tell me what is the value of f of negative 4? And at first that looked kind of confusing, and I had people trying to solve for x. And it's like, no, you're not solving for x. You're saying x is negative 4, right?
Yes.
And you'd say, well, okay, well, negative 4 minus 7 is negative 11, right? And then you realized how easy function work was. And when you put in a negative 4, you get a negative 11 out. And you're like, hey, this function stuff is simple. So in this chapter, what we're doing is we're putting functions together, multiple functions together, and our functions aren't going to be quite as simple as just these linear functions. So we might have some that have some fractional exponents or might have some roots to them, you know, something that more reflects what we've been doing in class. So it would be nice if we could do those functions all day, but we are not, all right? So for these examples, we're going to define our functions as follows. F of x for these examples are going to be x squared plus 5x minus 7. G of x we're going to define as x minus 8. And h of x is going to be defined as the square root of x. And I'm often asked why do we always use f's and h's and g's as names of functions. Really, I'm not quite sure why we always start with those letters. Maybe because the word function starts with an f, that's why we always start with f. And then they just kind of go alphabetical from there. They usually skip over the letter I, but if they have multiple functions, they'll use f, g, h, and then j, k, l, m, n, and they just keep kind of going from there. But they're just naming the functions. They're just identifying which ones you're going to use, especially when they go to combine them. So we're going to start off with just adding, subtracting, multiplying, and dividing. So just some function operations. So if I said, hey, what would you get if you added f of x and g of x? What do you think you would do there? You would just add those equations, you bet. It's just straight substitution. So f of x we would put in parentheses x squared plus 5x minus 7 plus, and then g of x would be x minus 8. And then if we could combine like terms, which we can, we would always want to express our function, our new function here, without any parentheses. So there's our new function. So how about you guys show me f of x minus g of x? Good. Good. No, I'm so impressed I'm not tricking anyone. Usually on a test or something, I'll really mess up some grades here. Apparently you guys are willing to take the extra time today. Make sure you do that on a test too. So I like that you're using your parentheses here, and you are willing to write it out without parentheses, and you are distributing that negative, so you have negative x plus 8, and then when you combine like terms you get plus 4x plus 1. A lot of times we'll get the plus 4x, but then we won't get the plus 1 because people won't take the time to distribute that negative. So nice job. I'm impressed. All right, what if we had, I wanted to do h of x divided by g of x. What would that look like? Don't let the simplicity of this get you mixed up. It's just square root of x over x minus 8, right? You can't simplify anything. So guess what? You're done. This is it. You can't simplify anything here. It is over, right? What about g of x times f of x? It is multiplied. Right, something like this. X to the third minus 3x squared minus 47x plus 56. Okay, so these are just practicing skills that you've been doing for a long time now, so we're not going to spend a whole bunch more time. It's just basic operation of polynomials, add, subtract, multiply, divide. Simplify where you can. Sometimes you can't simplify. Most of the time you can do a little bit. Combine like terms or multiply. So that's not really the important part of the lesson. The important part is something that we call writing composite functions. And that's really what I want to focus today and where the what your homework is over, okay? Because you've already done a ton of homework where you had to add, subtract, multiply, and divide with polynomials already this year. All right? So this next part is called composite functions. And this would be the new information for today. And for this part, we're going to define some new functions for f, g, and h. For this one, our f function, f of x, will be defined as 2x minus 6. Our g of x function, g function, is x squared minus 5. And h of x function is going to be the square root of x plus 1. So the type of notation that you will see that will let you know that you're dealing with a composite function will look something like this. Okay? And the way we read that is f of g of x. So that's how we would read that, f of g of x. Another notation that you will see on some worksheets and in some textbooks for the same operation will be f, and then like an open circle, it's like a dot, but it's open. And then the g, it's read the same way, f of g of x. So if you see that type of notation somewhere, it is f of g of x, and it does the same thing as what we're talking about here with all the parentheses. I really don't know why we have different notation to represent the same thing. I just want to make you aware of that, okay? So with composite functions, instead of just putting a number in place of x, you actually put another function in place of x. Here's my recommendation on how to do this. The people that follow my recommendation usually get them right. The people that try to skip steps and you're like, hey, I got this, I can do this on my own, I don't need to listen to this stopper, usually screw it up. You can make your decision where you want to do this, all right? But I'm telling you, this is the process where all of the students get it right if they follow this step. I start with the f function. I say, okay, what does the f function do? And I use words that do not include the letter x. Instead of using the letter x, I use the word something. What does the f function do? It takes 2 times something and subtracts 6. Do you agree with that? That that's what the f function does? It takes 2 times something and subtracts 6. So I say it first in my head. 2 times something, subtract 6. And then when I write it down, wherever I said the word something, I don't put an x, I use parentheses. So 2 times something, subtract 6. 2 times something, subtract 6. And then I stop. And I breathe for a minute. Right? I stop. Notice, I don't have anything else written. I haven't written an x anywhere, have I? 2 times something, subtract 6. And then I say, oh yeah, I'm not done yet. What's that something that I'm going to put in there? I got to put in g of x, right? And g of x is x squared minus 5. So then I go back to my parentheses and I write x squared minus 5. And then I need to go through the process of simplifying. So I'm going to distribute. I have 2x squared minus 10 minus 6. Which is 2x squared minus 16. So f of g of x, the composite function, is now 2x squared minus 16. Does that make sense? Perhaps? Okay, let's try another one. Let's try g of h of x. Let's use that strategy. What does the g function do? Someone say it out loud. What's it do? It squares something and then what? And minus 5. Okay, so let's square something and take away 5. Okay, what are we going to square? Square root of x minus 1. All right. So we're squaring a square root. Doesn't that just undo each other? Okay. Oh, plus 1. I'm sorry. I screwed up. Sorry. You guys are good with the details today. That's awesome. All right, so we square a square root. It undoes it, yes? So that leaves me with just x plus 1 minus 5, which is, yep, you're right, x minus 4. So there's my composite function, g of h of x. Make sense? Take that moment, right? Instead of saying the letter x, you say something. Then when you write it down, whenever you say something, you go ahead and you write parentheses. If you keep saying x all the time, way too many x's flying around here, right? You try to write it all down at once because Miss Starford doesn't know what she's talking about. I can do it all in one step. I'm bright. I'm smart. You will make a mistake. I've been doing this for a long time. And if I have to write a composite function, this is exactly what I do. I don't do it all in one step. There's no way. I will make a mistake. I write down what the first function does. I say the word something. I write a parenthesis for it. And then I take a breath. And then I go back and I say, okay, oh yeah, what are we putting in for that something? And I put the other function in it. Let your brain re-register what it's doing. One function at a time. Make sense? Cool. All right. We are done with that then, and you've got your homework.